All right, welcome class to our first section of soils. It's awesome to have a few of you guys here already ready to go. Make sure you have this book right here. If you don't have it, please let me know. Please let me know in the chat right now, or let me know through email or in the comments below of this video, all right, so we get you set up. So we have finished the circulatory system and the respiratory system in science so far, and I hope you've really enjoyed doing those activities and learning more about our bodies and how it functions. So now we're going to dive into learning about our world, our earth that we live on. And so our first section is going to be these soils. And so if you have this book, I would go grab it and make sure you have it with you, and you can open it up and follow along. I do have it. I will have it up on the screen, but it might be easier to follow along with the book in your hand, and you can be able to might be able to see it a little bit better. And then also in the back, if you've already started, in the back of the book is our glossary, and this is what you're going to be using to fill out the vocabulary. All right. So let's get started. Let's pull up this. All right, I do have the chat commands again. So we will have a few questions as we read through this to make sure that we're paying attention and following along and staying focused and learning what we're supposed to be learning. So I will be asking you questions, and I want you to answer them in the chat box, or you can answer the questions in the comment section below this video for those that are watching the replay. If you forget the question, you can use this chat command here in the top right corner of the video to know how to type the chat command so that the chat box will bring up the question, all right, to help remind you. So let's get started. Right here on my screen is page number 2. So if you want to flip to page number 2, make sure that you're following along and staying focused. We want to discuss, actually, let's go to, one second. Oh man, I might have actually did the wrong, did I do the right questions? I might have produced the wrong questions for you guys. So the chat commands might not even work, and that's my fault. So I will type the questions in the chat box so that you can see them and be able to see them. Yep. So let's take those off. All right. So let's actually look at the cover of this book, all right? So we're going to look at the cover and look inside and figure out kind of how the first few pages will be helpful with us learning from this book, all right? So if you look at the cover, we see soils, and right here at the bottom of the thing, it tells us a little bit about soils. So if you want to read that, and I'll read it with you. It says, soils are made from weathered rock and the remains of plants and animals. Soils also may contain many living things. All right, so the cover of books usually give us some information about what we're going to learn. And so it's always good to look at the cover. And then if you look at the contents, the table of contents page, this will also be a good resource to help you understand and help you get ready for all the things that you're going to learn. Some of the chapters are what is soil, and the last 2 chapters are how are soils alike and different, and why and how should we conserve soil. And so those are the things that we're going to be learning. We're going to be learning about what soil is, how it's formed, how soils are alike but also different, the different types of soils and the properties of them, and then why and how we should conserve soil, why it's important that we should conserve soil. You might think about dirt, and if you go outside and you look at, the soil that's around your house, you might be like, why should I even worry about soil or conserve it? And we're going to learn that it's actually very important to conserve soil and how we do it. All right, so now let's get to this page, which is on my screen, page number 2. All right, so let's read. I'll read aloud, and I want you to follow along either on the screen or if you have the copy with you. All right. So, building reading skills. Preview the book. You read nonfiction books like this one to learn new information. Previewing the book will prepare you to understand and remember what you read. First, look at the title, front cover, and table of contents. Based on these features, what topics do you predict you will read? We were just talking about that. We're going to learn about soil and the different types of soil, how soil is formed, and how we should conserve. So next, look through the book page by page. Skim the headings and the words in bold type. Glance at the pictures and read some of the captions. Notice that each main section of the book begins with a 2-page paragraph. What other special features do you observe in the book? So as we scroll through the book, what other features do we look? Or what other features do we see? Those that have your hard copy with you, it's easy to do this. Just start kind of flipping through the pages and see what we see. Well, things that I see are pictures and headings underneath those pictures right here. So those are some different features that I see. And right below, it talks about headings, captions, and other features of nonfiction books are like signposts on a journey. They can help you find your way through information. They can also help you connect new information with you already know. So, let's jump into, I think, the next page. All right. Okay. So, we talked about building our reading skills. Sorry, I'm just looking at my notes. We talked about building our reading skills by using what we read on page 2 about flipping through the book, looking at the front cover, table of contents, flipping through and seeing the different features that the book offers to help us understand what we're going to be learning and being prepared to learn the information that's inside. Okay. All right. So our first science statement is, what do you think weathered means? What does weathered mean? If something is being weathered, what is happening? If you think about we talked about mountain ranges in history, and we learned about the Appalachian Mountains, and we also learned about the Rocky Mountains. The Appalachian Mountains are in the East Coast, and then we learned about the Rocky Mountains, which we live really close to and through. Rocky Mountains are here in the western part of the United States. Do you remember what's different between these two mountain ranges? Do you remember what mountain ranges have the taller mountains? Remember, we talked about this in our history lesson. We were looking at physical maps. The Rocky Mountains have the tallest mountains here in the United States. And we learned that the Appalachian Mountains are smaller. And are they smaller because that's how they were built? Or are they smaller because they were older and have been weathered through erosion? So weathering is something that is being weathered, is being eroded. From natural processes, things are broken down and eroded. And that's a huge part of how soil is formed. So weathering and erosion is part of the process of soil being formed. And we're going to learn about weathering later in our science section. So don't feel frustrated if you didn't understand what weathering means. So that was our science statement. So now let's jump into page 3, which is here on my book, and those that have the hard copy. You can flip to it. Looks like this, right? Same thing as that's on the screen. So what is soil? Let's make a connection. A tree grown in a crack in a rock, as this one is, right here on the page, may eventually get large enough to split the rock in two. This action is the first step in soil formation. How do you think soil could begin to form from a broken boulder? So let's think about that question, all right? And then have you seen other examples like this with plants growing in between things that you don't think plants would grow? So if I were to walk outside my front yard, I have a kind of a brick paved porch area in my front, like right outside of my house. And I have all these weeds growing. Maybe if you walk outside your house and walk on the sidewalk, you can see plants or grass or weeds growing in the sidewalk. So that's a really similar thing to this going on right here. So soil could begin to form from a broken boulder because soil has small pieces of rock in it. Maybe when rocks are broken down, they become part of soil. So that's a possible answer for making the connection between what's going on and the formation of soil. Okay, so let's jump to page 4 and start reading. So make sure you're following along here on screen or in your book. And we're going to learn some key vocabulary words, all right? Okay, so much of Earth is covered by a loose material called soil. Different soils vary in color. In the way they feel different soils vary in color in the way they feel to the touch, and the amount of water they can hold, and how well plants grow in them. However, all soils consist of 4 main ingredients, and this is important. You'll be tested on this later, all right? So let's pay attention. All soils consist of 4 main ingredients: rock pieces, air, water, and a material called humus, or humus. Looks like hummus, but it might be pronounced humus. Sorry, I should have double checked on that. Let's take our book and go back in the glossary really quick. Humus, there you go. So the glossary has the pronunciation right there. It's kind of brighter there, you might be able to see it, but if you have your book, flip back, humus, all right? And we're going to learn about actually, since I'm already back here, I'll just read the definition of humus. It's decomposed remains of plants and animals in soil. So that's one of the main ingredients in soil. The main component of soil is rock that has been broken down into tiny particles. Rocks are earth materials composed of one or more minerals, which are solid, non-living, natural substances. For example, granite is a rock that typically contains the minerals quartz, mica, and feldspar. Some of you guys might have granite countertops in your house, or maybe just a quartz countertop, which is just part of the mineral that is in granite. It's a little bit less expensive than granite. All right, and then humus, the broken down remains of living things, is another important part of soil. After animals die, their bodies slowly decay or break down. Plants and other organisms also decay after they die. These decaying materials, along with decaying animal waste, become the black or dark brown material in soil called humus. Humus helps soil absorb and hold water, and is also a source of nutrients. Nutrients are substances that plants require in order to grow and develop. All right, so we just read a lot. And it might be a lot to grasp, but luckily we have these pictures that kind of help us understand and grasp what we read. So if we look down at these pictures, we have this first picture on the left of leaves. And let's read the caption. Dead leaves break down and become a part of soil called humus. Sorry, I'm going to close that. And again, humus is decomposed remains of plants and animals in soil. So humus adds nutrients to soil, making it good for growing plants. So the decomposition of plants and animals is important because that's how soil gains its nutrients. And then here on the picture on the right, let's read the caption. Soil is a loose earth material composed of tiny rock pieces, humus, air, and water. Soil covers most of the land on Earth's surface. All right, so again, you're going to be tested on the 4 main ingredients of soil. So let's recap that really quick. The 4 main ingredients are rocks, rock pieces, air, water, and humus. All right. And we read what makes up the biggest part of soil. And right there, the second paragraph, the main component of soil is rock. So the biggest part of soil is broken down rock. All right. All right, so let's continue on to page 6. Okay. And some questions that I'll ask to help us get ready is, how is sediment made? So we're going to learn about sediment, and so let's focus and pay attention to how sediment is made. And the next question that I will ask after we read this page is, what are some natural forces that can weather rock? So we talked about weathering at the beginning of this lesson. So let's learn some natural forces that can weather rock. I think I lost the chat, so I don't know if you guys are I don't know what's going on. I don't know what happened right there. Weird. All right. Well, anyways, I'll just keep going. All right, page 6. We have these pictures that we can look at right now, and then after we're done reading, we'll point these out and read their captions. Air is another part of soil. Air fills the tiny spaces called pore spaces between the solid particles of rock and humus. As worms and insects tunnel in the ground, they also create spaces that fill with air. Plant roots need air in order to stay healthy, so these air spaces are important for plant growth. Water is the final component of soil. Like air, water fills the pore spaces in the soil. After it rains, water seeps into the ground and replaces some of the air in the soil. The 4 parts of soil are not found in equal amounts. About 45%, or almost half is 50%, of soil is rock and mineral particles. So about half of soil is rock and mineral particles. Humus, although very important in supporting plant growth, makes up only a small part of most soils, typically 5% or less. Approximately 25% of soil is air, and another 25% is water. So let's break that down really quick. So we learned that the biggest part of soil is rock and mineral particles. Sorry, that's a bad spelling of rock. Sorry, guys. Again, it is a little tough writing with my mouse. Rock is about 45%. All right, and then humus, which is very important, right? It provides the nutrients to soil. Humus. I want to say humus, makes me hungry. Is only a small percentage. A small percentage, but a big bang for its buck, right? It provides a lot of nutrients for soil. And the rest is air and water. And how much percentage does this make up? Well, we have 45% plus 5% equals 50%. So that's about half of what soil is made up of. And we have 2 more materials or components of soil. Well, they both make up about half of 50%, which is 25% each. All right. Okay. Earth's covering of soils provides a home for many living things. Almost all plants must have soil in order to grow. Ants, earthworms, beetles, fungi, and many other organisms may live in or on the soil. Soils also contain tiny bacteria, living things to see without the help of a microscope. Living things too small to see without the help of a microscope. One handful of soil may contain billions of these tiny organisms. All right, again, a question. What are the four main components of soil? They are rock, humus, water, and air. Can't really do air. There you go. All right, let's look at these pictures again. What living things do you see in these pictures? Looks like we see ants. And this picture talks about the movement of ants and other insects through soil creates pore spaces that fill with air and water. So living things help create the pore spaces in soil. Rainwater seeps into tiny spaces between rock pieces and humus. It becomes an important part of soil. Soil provides a home for many living things, including almost all plants. Plants get the water and nutrients they require from soil. So what makes up the biggest part of... Oh, we already read that, sorry. How is sediment made? Wait, that's the next page, sorry. Yep. So now we're going to page 6. Now we're going to learn about sediment. See right there is our key vocabulary word. We're going to learn about weathering and sediment. So how is sediment made? And then what are the natural forces that can weather rock? That's what we're going to learn about here and be able to answer those two questions. New soil, so starting at the top of the page, follow along. New soil is constantly being made all over Earth. However, soil formation is a very slow process. It can take 1,000 years for just 2.5 centimeters, about 1 inch of soil to form. So if I were to take my finger like this, that's about 1 inch. So 1,000 years to make this much soil. So that is a long time. All right. And I think knowing that is also going to help us know why it's important to conserve soil. If it takes so long to make, we got to do our best to conserve the soil that we have. All right, weathering. The first step in the process of all soil formation is weathering. So let's flip back to our glossary and point out what weathering is. All right, so if you have it there, follow along and read it and follow along with me. Weathering is the breaking down of rocks and minerals into smaller pieces by water, wind, temperature changes, and living things. Right here, the breaking down of rock. So weathering, the breaking down of rock into smaller and smaller pieces. The result is sediment. So weathering, that process of weathering breaks down rock into smaller pieces, and the result is sediment. So sediment is the rock and mineral particles that make up most of soil. So again, let's look back in our glossary. We just read basically the definition of soil, but let's see if the glossary has anything else to add. Sediment is rock and mineral particles that are produced by weathering. So if the biggest component of soil is rock and rock minerals, well, now we just learned that that is called sediment. Sediment is the rock and mineral particles that make up most of soil. Remember, about 45% of soil is made of sediment or rock and rock mineral particles. And that process is started by weathering. Weathering occurs through the actions of natural forces, mainly water, wind, temperature changes, and living organisms. Whenever the rock or earth surface is exposed to these forces, soil can begin to form. Water is a powerful weathering force. Over time, moving water in rivers can tumble and break rocks. Crashing ocean waves can wear away solid rock cliffs. Water can also seep into cracks in rocks. Water reacts with and dissolves the minerals in the rock, breaking them down. If the water freezes, it expands or gets slightly bigger. The pressure forces the rock to split apart. Wind causes weathering when it blows particles such as sand against exposed rock. The sand acts like sandpaper and scrapes pieces of the rock. Temperature changes also weather rock. In the hot sun, rock expands, and at night they cool and contract or shrink. Over time, this process weakens rocks, which may crack and break apart as a result. Sorry, that's a little glary here. I just took pictures of the book. I'll be right back. I'm going to grab something, a cool little thing I want to show you about what we just read. I should have had it first, but I forgot. So I have this is a mason jar, right? A glass jar. Well, focus. And one night I wanted to cool my water really quick, and so I put it in the freezer instead of the fridge. But then I forgot about it. And we just read about what happens when water freezes. What does it do? Come on, you can do it. Say it out loud. It expands. So look what happened to my mason jar. Look, it cracked multiple times. Right? So that's how water can break up rock. That's how weathering in water, that's how water can weather rock, right? Is by expanding. And right here, some pictures down here of the constant pounding of water against these rocks, and you can see that these hills on the side, these mountains on the side of the ocean have been pushed away and flattened because of the rock. And then right here, these rocks were broken by freezing water. Remember, water expands as it freezes. You can see all these cracks that took place. Oh my gosh, sorry, I didn't have the screen up right here. So this is what I was talking about, sorry. Right here, this picture is the water weathering away the rock faces next to the ocean, these mountains, these hills, and flattening them. And then this picture on the right is water expanding and cracking these rocks on page 6. So living things such as plants can also weather rock. If a tree root grows into a crack in a rock, the rock may break apart as the plant root grows. Maybe you've been walking on the sidewalk or on the road, and you can see how the sidewalk is broken up, and you can see that a tree is close to it, and maybe you even see the root coming. Maybe you've experienced that before. Lichens are organisms that live on rocks and produce chemicals that eat away at rock surfaces, causing weathering. So plants, water, air, can all be part of the process of weathering. And weathering breaks down the rocks into rock minerals and small rock pieces, which then become sediment, and sediment makes up 45% of soil. Erosion, sometimes sediment remains near the rock from which it formed. In fact, most sediment in soil comes from the solid rock right beneath it. However, rock particles may also be carried far from the place where they were made. The movement of weathered particles from place to place is called erosion. So, if I have some rock that's being weathered from my house, and then it gets carried away to your house, that's kind of like erosion, right? It's being moved from place to place. And we're going to learn that some rock or weathered material gets eroded even a farther distance than from our house to your house or our house to the school. Erosion, like weathering, can be caused by many different natural forces, including moving water, wind, moving ice, and gravity. Rainwater falling on loose soil can wash away sediment from land. Rivers and streams can carry sediment from riverbanks and streambeds into lakes and oceans. Ocean waves can shift sand and reshape beaches. During floods, large amounts of sediment may be picked up and moved into a new location. Wind can also cause erosion, pushing sediment along the ground or lifting it into the air and carrying it away. Sand dunes on a beach or in a desert form where wind blows and blows sand from one place to another. So here's a picture of lichens. Remember, they're organisms that grow on rock that can break down rock through their acid. And then here's a picture of erosion with water eroding these rocks and the dirt and sand on the side and carrying it away. All right, 2 more pages for today, all right? So masses of moving ice called glaciers. This top picture right here. Glacier is a huge flowing moving mass of ice. So it's looks like it's still and stable, but it's actually moving, which is pretty wild. So these glaciers can also transport sediment and rock. Sometimes materials freeze into the sides and base of a glacier and travel with the glacier as it flows. A glacier may also push material in front of it as it moves. As a bulldozer pushes whatever is in its path, gravity is the force that pulls materials down towards Earth's surface. Gravity can also cause large amounts of loose rock and sediment to move downhill suddenly during a landslide. Gravity might also pull Earth material downhill gradually over a long period of time. So we've learned about how water, air, ice, and now gravity are all parts of erosion, or all play parts of erosion. When moving water, air, ice slows or stops, it drops the sediment that it is carrying. Material eroded by gravity may come to rest at the bottom of a slope. The dropping or depositing of sediment, remember sediment is rocks that have been broken down into small rock particles or rock minerals, in a new location is called deposition. So let's pull up our glossary again. Deposition, use our little sound guide. The dropping of sediment in a new location by water, wind, ice, or gravity. For example, imagine a strong wind blowing sand across the desert. When the wind dies down, the sand falls to the ground. This is an example of deposition. When gravity erodes materials, they usually are deposited at the bottom of a slope. Sediment eroded by water or wind is deposited by size. Larger and heavier sediment, such as gravel and sand, is deposited first. Finer sediment, such as silt and clay, is carried farther since it is lighter. This natural process of depositing sediment by size is called sorting. So bigger materials get deposited first because they're harder to carry through these natural forces such as wind, water, ice, gravity. And the lighter, smaller particles that are called silt and clay are carried farther away because they're easier to carry. All right, so our last page, decomposers. After sediment is deposited in an area, plant seeds may sprout and take root. The growing plants in turn attract insects and other animals. The waste from these animals become humus. In time, the plants and animals themselves die, and the remains also become humus. The process by which dead organisms and their waste sorry, one second. I was trying to see if I can pull up the chat. Nice. Okay, I finally can see the chat now, guys. So if you have questions, please let me know. I couldn't see it at first, so now I can see you guys if you guys have anything. All right, you guys are talking about Nightbot. Nightbot is to help us stay focused, guys. So the Nightbot is my member assistant teacher, and he is there to help us stay focused. All right, so he's gonna help us, remind us to stay focused. And we only have 1 more page left. All right, so let's finish this page, and then if you guys want to chat a little bit amongst one another, I'll let you guys have that opportunity. All right, so the process by which dead organisms and their waste are broken down and returned to the soil as humus is called decomposition. Decomposers are living things such as bacteria, insects, and fungi that help decompose plant and animal matter. The humus that results from decomposition adds nutrients to the soil. Earthworms are particularly important decomposers. An earthworm typically eats its own weight in soil and decaying organisms every day. As this material passes through the earthworm's body, nutrients are released. Some of the nutrients leave the earthworm's body in waste called casts, which enrich the soil. If you have a question, Scotland, that's fine. You can put it in the chat. It'd be awesome to help you out. Earthworms improve the soil in other ways too. Their burrows help water drain through the soil and allow air to circulate. The burrowing also spreads nutrients by mixing the soil and creates spaces so that plant roots can easily push down into earth. All right, so what are the roles, this question right here, what are the roles of weathering, erosion, and decomposers in soil formation? So I'm asking you guys, so those that are here live, let's answer this question. Put it in the chat. And those that are watching the replay, you can put it in the comments below. What are the roles of weathering, erosion, in decomposers, and soil formation? How do those three things impact soil formation? All right, guys, let's answer this question. Scotland or Caden, whoever else is here. I only see you guys, YouTube chatting. All right, Scotland, Caden. This question right here on page 9. Let's answer this question. What are the roles of weathering, erosion, and decomposers in soil formation? There's no hint for these ones. Sorry, guys. I hope you guys were following along. If you were following along, you should be able to answer the question and paying attention and staying focused. I know it's easy to get distracted when we're doing these live lessons or on the internet. We gotta I don't know what that question is, Scotland. Where do childs of the earth come from? I've never even heard of that, so I have no idea. But let's answer this question. Come on. What are the roles of weathering, erosion, and decomposers in soil formation? All right. If you look at your page, it offers an answer to you right there on that page, right below the question. All right. Remember, at the beginning of this lesson, maybe you guys weren't here, but those that are watching the replay, if we skim through the book, and we look at the different features that a book has, we can learn a lot about what we're going to learn. And one of the features that this page has is some pictures and a caption here on the right. Decomposers, such as insects, earthworms, and mushrooms, and other fungi, right here's the answer to the question, break down dead plants and animals and return nutrients to the soil. So decomposers are a big part of creating the humus that is found in soil, all right? Weathering and erosion breaks down, rock, and erosion carries that broken down rock or sediment, right? That's what sediment is, broken down rock and minerals, and carries that to different parts of the earth. And sediment is a huge part of soil. It makes up 45%. All right, so that is our lesson today. If you guys want to chat amongst yourselves, you guys can. I understand that, Scotland, that people that are around you could be loud. If you have headphones, when we're doing these live lessons, headphones probably would be helpful and kind of drown out the sound around you. But I'm glad you're here. It's awesome having you here, Scotland and Caden. The question was this one right here on page 9. What are the roles of weathering, erosion, and decomposers in soil formation? But that's going to be it for today, guys. Your assignment for these first few pages, pages 2 through 9, this first section, are right here. The reflect on reading and the apply science concepts. So you can find that assignment on Canvas, and obviously you have your book to skim through. Nice, you're going to say that. Good job, Caden. Well done. So, not going to give any answers for those because those are for your assignments, but reach out if you guys need some help. But that's going to be it for today's lesson. I'm so glad you guys were able to make it. I hope you enjoyed it. We will have open office hours in about an hour, hour and a half. So if you have questions, you can come in and ask me there. Again, those are going to be on, well, I might not be on Tuesday anymore because I might be going into school. So it might be on Mondays and Thursdays, but I'll let you know. Remember to get caught up with math and literacy and focus on getting caught up on those. Those are very important. And then on the side, you can make sure that you're doing your best to do the history, science, and literature stuff. Make sure you're doing the reading. But again, I know that the principal and the administration really wants us to make sure that we're caught up and on track with math and literacy. So do your best to do that. Nice. Good job, Scotland. You're going to say that too. Good job. Okay, well, that's going to be it. Thanks so much for coming in, guys, and those that are watching this. Hope you enjoyed. We have some awesome things that we're going to cover in the science section. But that is going to be it for today. Catch you guys later.